Hey everyone, today I'm going to be working on an interesting problem. Um, I'm not sure if you've heard, but foreclojure.com is closing down. And I kind of started building this forever closure, which is completely static website. And I'm using the SCI interpreter by Bogdude, which evaluates the code in the browser itself. So this is pretty cool. There's one problem which I'm trying to solve is that there is no difficulty level mentioned here. So if you've seen the original foreclojure.com, you can see like they have this difficulty tag. But the data set which I got from another repo did not have that. So let's check the data set which I got from this repo, which is problems.clj. So I have this clojure file with a problems map list of maps, right? And I kind of want to add these difficulty and maybe even the topics, right? Even if I can add the topics as well. So today I'm going to try and solve that. So let's go back to our GitHub repo, and fortunately, Lawrence over here has scraped scraped this page, and he's attached a really nice um, Excel sheet, a CSV sheet. Let's check that. Okay, so if we look here, we have the difficulty here in this column. We've got the name of the problem, and fortunately we do have the URL as well, so we can kind of I think we can kind of parse the IDs out of this. These are the ID numbers. We probably don't want this. Let me edit this. We don't want ID. We don't want. Okay, so we do have topics, right? So let's call these tags. Let's call this difficulty, and so this is what we need. Let's get rid of all of this. We don't need any of this. Awesome. So let's save this under, and let's save this as list.csv. Awesome. So now that we have this, we kind of need to parse the ID. We need to figure out the difficulty level, and then we need to rewrite our existing clj file, right? So we have this data.cljc file, which has this ns data and def problems. We need to rewrite this with the merged values. So basically we want to add another key here with difficulty and tags and the value itself. So yeah, I think there's an easy way. Just load this edit into memory, load that edit into memory, merge it, then copy paste it here. But you want to do something crazy, so I'm going to try and use rewrite clj to do this. So let's get started. The first thing I'm going to do is I'm going to copy the list.csv here in the foreclosure project, and I also am going to launch Emacs, and I've created this bin/example script which is going to use babashka. So let's actually go and launch a babashka repl. We've got a repl on 33173 port, and let's connect localhost 173. Yeah, we really need a cider jack and babashka, and I think we have our repl connected. So let's test it out. Yep. So let's load some of these requires, and let's also load the right clj, right? Fortunately, babashka already provides us, and we need the zip version. So as zip, and what we now need to do is we need to read the CSV file. So again, fortunately, babashka already has a CSV alias. So let's do that. With open, let's create a reader. Let's give it a file with, what did we name it? List.csv. And we need to read this, right? So let's go with CSV, read CSV, and let's evaluate this. stream closed. Hey, okay, yeah, this is a lazy sequence, right? Awesome. So we've read the CSV, um, but we don't want it in this format, right? Like we need maps. We don't need lists. So let's actually go to. So I've used this before. Basically, the documentation in data.csv, clojure.data.csv has this amazing helper function which turns the CSV into a map. So let's copy paste that, eval it, and let's thread it. If I do CSV data maps, we check this now. We've got maps. So this is great. This is awesome. Um, let's save this in a data, and now yeah. So now I have data here. So I've got the CSV data loaded, right? And what else do I want here? Okay, so so one thing is I want the IDs, right? So I kind of want to parse this. I don't want the URLs, and I kind of uh is is tags always space separated? Um, most of the tags are empty, right? And when we do have tags, they're space separated. So I think we can convert the tags into a list. That might be helpful. So let's kind of do that here, right? Got this. Let's map it. Actually, this is a perfect use case for a transducer. So let's do it that way. So let's do into a list. Let's map this to a comp with a map. I'm going to first of all sock and ID, and this ID is going to have the URL function, right? So I kind of parse the URL, the element, and let's just run this and see if that works. Right, so now I have URL which is the same as ID, but I kind of don't want the URL. I actually want to do a string slash replace. Let's say I kind of want to replace this with an empty string. Does that work? String replace, um, then S, then the match, and then the replacement. Yep, I think that should work. So let's eval this again. Awesome. So we've got the ID, but we also want it as integers. We've got the 00 ID. Something's wrong. Okay, I think I've taken one extra. And let's also do an integer slash parse int. Perfect. So we've got the ID. The next thing which we kind of want to do is get rid of the URLs, right? We don't need the URLs. Let's do that. Let's put this sock on the URL. Awesome. So we've got difficulty tags ID. But again, we don't want, we kind of we kind of want tags as a list, right? So let's do that as well. I think map, I'll have to use the string split function, right? I think that should just work. Split edge, or maybe, oh no, so I kind of want to update the tags. So I kind of want update and tags, then I need to give it a function. So let's say tag string going to be string split. What is it? It's a string and then a regular expression. So the string is going to be tag string and a regular space. Does that work? Perfect. The problem is we don't want these empty strings, right? So we kind of want to filter tags with empty strings. How do we do that? But I think that's fine for now. That works. So let's also yeah, I think that's enough, right? We've got the ID, we've got the tags, and we've got the difficulty. Sweet. I think we can add this to a variable. Let's call this data2. Yeah, really, I don't have a better name. Okay, we've got this data, but now so now we've got this data passed with IDs. We kind of want to add these here. To add these here, I need them in the prob data.clj file, right? So I need it here. So I kind of want to add this inside of these data. So let's look at using rewrite-clj for this, right? Let's see if it's working. So I'm going to take so rewrite-clj kind of works with zippers, right? So zipper is a tuple. The first element is a tree and the second element is a pointer, a place in that tree. So let's create a zipper first. Let's read. Yep. There is an off file and there is an off string. Let's actually work with a string. Let's copy this part. Let's just write a string manually here. And let's add like two elements to it. Let's add ID1. Let's ID2. So let's actually check what is in zlog. So the zipper has this structure right now. Okay, so we've got the first structure, which is maybe the file, the string, and where is ns? Okay, so the first child is value ns, the second is a white space, and the third is app.data. So we basically have the first ns app.data here, and then we've got this other nodes, right? The children nodes. So one of them says okay. Okay, so this is the children which kind of goes in here. Let's not try to and let's not try to read the structure. Instead, let's actually work on it. So let's take the zlog function and let's go down one level. So let's do a zlog down and let's also print the node. So if you actually try to print the node on zlog, let's see what do we get. I do this, or maybe if I just do s expression, get rid of the node. Okay, so the first zlog is the app.data, and if I go down and then do as expression, that's ns. Okay, so we don't want to go down here. The thing is, we just want to find problems, right? We want to find this particular symbol. We just want this particular symbol. So there's this function in zipper rewrite clj, which is z slash that. Awesome. Right, so we don't want ns, we want to find problems. So let's do that, and bam. So what this is doing is it's kind of traversing the structure. So it goes from ns app.app data, then it's going to go to def, and then it's going to reach problem, because Znext does a depth first search, and as soon as it hits problem, it's going to find that node and return it to us. So let's thread over this. This basically returns us another zipper, right, which is a new tuple of two elements. So let's do that, and now what we want to do is we want to go down into the, so we want to go to the right of the problem. So this is a sibling, this list which we have, which is actually complete. Oh no, that's right, we want to go to the sibling. So let's do a z right and let's do a z sx. Right, so we've got this list, amazing. And now we want to edit this list, right? So let's right, so I think there can be two ways to go about doing this. One could be that I edit the entire value. So I basically create a new list and then I replace or maybe edit in place for the values of the node. But I think that would mean that I might lose any comments in this particular node. Do we have comments in data.clj search for hash? Okay, so we do have. Okay, no, so this is a part of the string, and we have semicolon. Oh, we do have comments. Oh my god, there are a lot of comments. So I'm not 100% sure if we'll end up losing this, but let's do it the easy way first, and then we'll see if we do lose it or not. We've got this node, right? And now instead of that expression, we are going to use a function zedit. So zedit takes a zlog, a function, and then the arguments. So our function is going to be basically what we are going to change. So we have this data, not data again. Let's use something else. Everything is data. Let's use problems. And for each problem, we kind of want to merge this, right? So again, this is a perfect use for a transfer. Let's do comp. Let's map problems here. Oh, what's in our data too? I kind of forgot. Right, so we have this, and we now need to match the IDs from data 1. No, we want to match the IDs from the problems, each individual problem, to the data 2 specifically, right? Right, so we have data 2 and then we have problems. Okay, so I think I'll have to change my data representation for data 2 a little bit. Instead of giving us a list of maps, let's actually make it give us a map of IDs to maps. So if I'm thinking right, so in our last function, right, when we get the map, now we also want to create a hash map out of that. We get a hash map. For this, we kind of want the ID, and for the second part, we can do it as a map. So let's perfect. So now that's the power of into, by the way, right? So now I have a map with ID and its particular data. So now I think it's going to be really easy to match from underscore ID to this particular data. So I think, yep, let's get rid of that. So I've got the entire problems list, and I'm iterating them one by one, and I want to do a merge. Inside the merge, I want the first problem, which has to be as it is. So that's the first element which we get. And the second element needs to be fetched from data 2. It needs to be get data 2, and then I need to pass in the underscore ID. That would merge both of them. That sounds about right. Let's actually try to see what we get out of this. So let's print it again using the Z expression. And is that right? Tags underscore ID, difficulty, elementary. Perfect, right? Perfect. I think that's exactly what we need. And since we're using a transducer, let's actually get rid of this underscore ID, right? Let's see. So why do we even have an underscore ID? Why can't it just be ID? Anyways, take it let's just remove the normal ID. Let's reevaluate this, and perfect. I think we're halfway there, right? We're full way there, I think. So now we only need to see if this actually works with the files. So let's do an off file. Does that work? Nope. Oh, that did work. It's just a huge file. Not a huge file. What is it? Oh, okay. 23 underlines. Okay, so we are getting the S expressions, right? Let's see if we're getting the comments in here. Pretty unlikely though. Search. Yeah, probably not. Where were those? ID 127, right? Yep, we're not getting the comments. That's fine for now. I think the problem will be we've not handled the null case, right? Like, what if we can't find the ID? Unsupported escape character. Okay, so it looks like there's some escape character issue which I can't figure out. So let's leave the new data function for now. Let's try the pure way of uh, the pure the pure way to do it through rewrite clj, right? Let's actually dive down into each particular map and let's append these child, the key node and the value node. So let's do that. Let's try doing that actually. So z find value, z lock, the next. Okay, so we got the first value, right? We got the first node, and then we can see that we have these child nodes, right? So what we want to do is we want to kind of loop over all of these nodes. So let's do that. Let's do a loop with a location, and let's give this a value. Let's call this a problem lock. Once we have that, let's start it with a problem lock. So once we are in here, actually we need to check if this is the last sibling or not. Because if it's the last sibling and we try to go to the next sibling, it's going to give us a nil error and we'll kind of lose the state. So let's do that. Let's check for a nil on the right. So if the next sibling is empty, is a nil, then just return the current element, right? I think that doesn't seem right because we'll kind of end up not mutating the last sibling. Anyways, I think we'll figure that out later on how to fix that. And once we have that, our other condition, so we recur, we take the current position, which is the location, so it's the current child, and then we merge. Okay, we're not going to merge this time, so um, we're actually going to add a child, right? So I think, yeah, let's do that. Let's do a z and child. Let's just give it any value for the time being. And since this is a map, let's also give it value. So I take the location, I do a z this, I do, and then I can do a z, right? So I kind of move to the next sibling. Does that seem right? Um, yep, I think that seems right. So let's that and rewrite lock. Let's include it the lead bindings. So once we have the rewrite lock, what we want is rewrite lock, and then I want the z root. Let's actually take this out so we don't have to evaluate this again and again. I think let's remove this part and let's actually split this out, right? Let's get an encoding it just.txt. Okay, perfect. So we've got an x and a 2. We don't want a word. We actually let's do that. Perfect. So as you can see, we went into this child node, right? We went into this node, and then so since we are on this node, right, we're appending a child to this map. So it adds an x and then it adds a 2. But now instead of x and 2, we kind of want to add uh, difficulty, right? And then we want the value of difficulty here. So let's do that. Let's lap it here. Let's do difficulty. Difficulty nothing but data 2, and that get something, and this is actually the problem. So actually we need the problem ID here, means create a problem. The problem will be from the it's going to come from the location, right? So I kind of want the z expression of location. I think that seems right. About right, actually. Okay. Um, I get the ID problem. I get the difficulty. I actually get ID problem, and then I get the difficulty. Okay, that's looks right. And eval. Perfect. We've got the difficulties. Amazing. Okay, we've got the difficulty, but the problem is it's not aligning very well. So let's fix that. Uh, let's add rewrite clj dot node as node, and let's append a child with node slash expecting one new line. Yep, that should work. And similarly, I can add spaces. Let's add 4 spaces. 4, yep, right. Get it out again. Let's open this. Oh my god. Did we just do it? Awesome. So we've got the difficulty. Okay, so we've added a new line, we've added spaces, we've added difficulty. The only problem is that our last node still does not have this element, right? Because as I said here, if we check on the current node that the next node is a nil, that just won't work out. So let's do something else. If we actually move and then check for nil, then we pretty much have it lost. We have lost the node. So either we can have one more node here, which is previous lock, and kind of check if the nil is lock, then return a previous lock. And when we are recurring, pass the location. So we get the new lock, then we get the previous lock. That should solve this problem. That's a quick fix, but I think there can be a better way to do this. Okay, so we've gone to source app data2.cljs, and bam, we've got our difficulty and we've got our tag. Let's also add space again. Okay, we've got our tags in the last one. We don't have the difficulties. That's fine. Um, okay, that's pretty much solved our issue. Just could commit this, right? And thank you.